Hello everyone. In this lecture, we will understand how to draw the equivalent mechanical system from a given mechanical system by using the nodal method. So, the first case is for the element connected to a node X and a stationary surface. That is the reference. So, we'll consider the first element, that is our mass, that is connected in between here we are applying a force F of t, because of which there will be a displacement x of t. Now how you will draw the equivalent mechanical system for this x of t, it will be represented by a node x of t. Okay, here this displacement is represented as a node x of t in the equivalent mechanical system, and the stationary surface as it is, and this mass m, it will be connected in between these two. So for mass, we have force is equal to mass into acceleration, that is d square x by dt square. Similarly for friction, here in equivalent in the given mechanical system, you will be not having any element here for friction. Just there will be an indication that there is a friction. So in equivalent mechanical system, you have to represent that friction by a dashpot, which will be connected in between a node x of t and the stationary surface. So for friction, the force is b into dx by dt. Next, similarly for spring, here this spring. So again there is a displacement x of t, and we are applying the force F of t, because of which there is a displacement x of t. In equivalent mechanical system, you have to draw it like this. That will be connected in between the node and the stationary surface. So for spring, force is k into x, that is k into the displacement. Now the second case is when the element is connected between the two nodes, that is x1 and x2, that is between the two moving surfaces. Suppose we have this figure here. It indicates that there is a friction here, and it is being shown by using a dashpot. There are two masses m1 and m2, and the force is applied on m2, okay, that is F of t, because of which there will be a displacement x1. Now here you can we have seen the previous videos or previous classes that mass, whenever there is a mass, we don't have any change in displacement. Okay, why? Because mass cannot store the potential energy, it can store only the kinetic energy, because of which no force is consumed here at the mass. So the force which was applied at m2, the same force will be applied at m1, but if they are connected directly to each other. But in between these m1 and m2, we have a dashpot which can store the potential energy, because of which it will consume some force, and the same amount of force is not being transferred to m1. So due to which there will be a change in displacement. So that displacement is represented by x2. Therefore this displacement x1, this displacement x2 is different. Okay, both are different. That is, there is a change in displacement due to this element in between the masses m1 and m2. Now how can you draw this in the equivalent mechanical system? Because there are two displacement, we will take two nodes. There will be one force applied on m2. Now this m1 and m2, even though there is a change in displacement here, this m1 and m2 cannot be connected in between two nodes. Always those will be under the influence of that particular node. So here this can be drawn as like this: x1, x2. X1 of t and x2 of t are the two nodes. Now at m2 there is a displacement x1, therefore m2 will be under the influence of x1 only. It cannot be in between x1 and x2, okay, because there will be no change in displacement, as these masses cannot store the potential energy. So similarly m1, it will be connected under the influence of x2. Now comes the frictional constant v, or the dashpot. So here this causes the change in displacement, and this will be connected in between x1 and x2, because here it can store the potential energy. Therefore there will be a change in displacement. So the friction can be connected in between x1 and x2. Here it is in between x1 and x2. Therefore, in the equivalent mechanical system, it is connected in between x1 and x2. So for friction, when this is the case, that is, you have change in displacement, the force can be given as b into dx1 by dt minus dx2 by dt. Similarly, for spring, when the spring is connected in between two nodes, that is x1 and x2, again same case here, f of t is a force which is applied to m2, then that force is passed on or transferred to the spring, where it will consume some force because it can store the potential energy, and the same amount of force which was applied on m2 will not be applied on m1, due to which there will be a change in displacement. So in equivalent mechanical system, we'll be having two nodes, x1 of t and x2 of t, and masses cannot be in between the two nodes. Those will be under the influence of that particular node. So mass m2 will be under the influence of x1, mass m1 will be under the influence of x2, and in between x1 and x2, spring is connected. So for spring, force is given as k into x1 minus x2 whenever there is a change in displacement, or the spring is connected in between two nodes. The third case is when the elements which are under the influence of same displacement gets connected in parallel under that node. Okay, it means that now here this figure you can see you have a stationary surface, and here you have a displacement x of t. X of t is nothing but the node. This is displacement here in the mechanical system. In equivalent mechanical system, it will be a node. Now here these all elements B, dashpot, spring K and the mass M, these are under the influence of the same node x of t. Therefore, these elements get connected parallelly under the influence of this node. You will get like this. You are having one node. These all elements are connected in between the stationary surface and the single node. Therefore, these will be connected under this node parallelly. Okay. Now, next case is, suppose this is the figure. Now what happens? So here you can see you have two displacements, x1 and x2. Now under the influence of x1, you have m1, b1 and k1. Okay. And in between x1 and x2, you have b2, k2. But m2, it is not in between x1 and x2, it is under the influence of x2. Why? Because mass cannot be in between two nodes. Okay, whereas friction and spring can be in between two nodes. Now we will draw the equivalent mechanical system for this. So how many nodes are there? Two nodes. Why? Because there are two displacements here, x1 and x2. Next you have m1. M1 will be under the influence of a single node only, that is mass. It can be under the influence of single node. It cannot be under the influence of difference between the displacements. So here this mass m1 will be under the influence of x1. Similarly, mass x2 will be under the influence of x2. Now under the influence of x1, you have m1, k1, b1. Therefore, these three elements will be connected parallelly under the influence of x1. Okay. Next is b2 and k2. b2 and k2, these are in between x1 and x2. Therefore, these two elements will be connected in between these two nodes parallelly, like this. Okay. So this is the equivalent mechanical system for the given mechanical system. This is how we draw the equivalent mechanical system from a given mechanical system by using the node method or the nodal method. Thank you.